Okay, in this additional video, I want to talk about some other aspects related to preprocessing, which could or could not be interesting for you. So the first of these appendices relates to skull stripping. And this becomes more and more important in order to provide functional MRI data which do not contain personal data. So it's a well-known fact that from a structural MR scan, you can reconstruct someone's face simply due to the fact that the anatomical scan contains very precise spatial information about all the different tissue types, including skull and bones. There are two strategies that to combat this problem. One of them is defacing, which means to obscure a subject's face in an anatomical MRI image, as is seen in the middle, in the bottom image. And the other one is skull stripping, which I would say is the better one because it completely removes the skull from an anatomical image. And based on what you have heard about segmentation and masking, how could skull stripping be easily implemented? You can now think about this question for a moment. If you want, you can also pause the video and then I will explain it. So if you take your structure MRI scan and segment it into tissue types, you get one tissue probability map for each tissue type contained in the image. And in order to remove everything that is outside the brain, which then includes the skull, obviously, we could add up the tissue probability maps for gray matter, white matter, and CSF, threshold this at a particular value, for example, 95%, and then multiply it element-wise with the anatomical image. And this then would give us the skull stripped anatomical image from which one cannot anymore reconstruct a subject's face. Okay, the second additional information that I want to share is about realignment. So I did a little experiment. These are the translation and rotation parameters that I got from spatial realignment of my functional MRI data. And what would now happen if I take the spatially realigned images and enter them into spatial realignment one more time? Once again, you can shortly think about this question. And the answer is that we get different realignment parameters from the second realignment, obviously. And you can here see that they are at a much smaller scale than the first realignment parameters. They're given in millimeters and degrees, and they are getting even smaller with the third and fourth realignment. And this very nicely shows that realignment works. Yeah. So if we are trying to realign images that already have been realigned, we are not able to estimate any great motion from these images because the motion has been properly removed. And I think the little variations that we still see here are simply due to the fact that we are not measuring continuous time series, but that we are only measuring the time series of activity and of movement at every 2 to 3 seconds, depending on which repetition time you're using in your functional MRI session. Okay, in the remainder of the slides, I'm also listing the references, so the books, articles, and websites that I've used to create this material. You are very much invited to have a look at these. And with that, I want to say goodbye again.